Hi guys, in this video, I'm going to discuss CPU architecture and microarchitecture. But first, let us know what is a central processing unit. CPU is the brain of the computer. It handles all computations needed to turn inputs from memory and outputs. The advancement in silicon technology brought into more silicon functionality onto the same piece of CPU. It is possible with the help of Moore's law. Moore's law is an observed trend where we can double the number of transistors per unit area about every 2 years. And this is the history of microprocessor. In 1945, it is the birth of digital computer. In 1946, the electronic numerical integrator and computer produced the first general-purpose computer. In late 1940s, John von Neumann popularized a new kind of computer architecture that simplified computer design and programming. It has a 3 separate systems, which are the bank memory, CPU, input or output interfaces, and 4-step instruction cycle, which are the fetching, decoding, executing, and write-back memory. In 1950s, the semiconductor-based transistors hit the market. In 1959, Robert Noyce introduced the integrated circuit, which combined multiple transistors in a single silicon chip. In 1968, it is the birth of Intel, or integrated electronics. In 1971, Intel made the Intel 4004 single-chip microprocessor. It is the first general-purpose programmable processor in one-time device. While in 1972, it is the release of Intel 8008. In 1974, it is the widespread of Intel 8080 microprocessor. In 1978, the Intel 8086 was created with 86X instruction set architecture. So now let's proceed to computing abstraction layer. The foundation of abstraction layer are atoms which can put together in silicon that can make transistors. Transistors act as switches. By connecting the switches together, we can form a fundamental Boolean logic operations with functional blocks. Chaining functional blocks allow more complex logical functions that creates execution units which perform specific calculations. The combination of these specialized processing elements is called microarchitecture. The instruction set architecture is the set of instruction that defines what kind of operation can be performed in the hardware. It is the abstract model of the computer and the dictionary of instructions. So now let's proceed to the microarchitecture. Microarchitecture is an implementation or specific design of instruction set architecture. So it has the key building blocks in CPU with several steps, which are the fetching or retrieving instruction from memory, decoding the fetch instruction, executing the decoded instruction, and write back, where CPU will store the result. When all put together, it is called the CPU pipeline. Pipeline is more likely an assembly line. The more CPU pipeline you have, the faster stages it can run. Modern CPU typically have 15 to 20 stages. The fetch and decode stages have 6 to 10 stages collectively. It is called the front end of the microprocessor. While the execute and write back have roughly 6 to 10 stages, that is called the back end of the microprocessor. CPU pipeline is synchronous, where each pipeline is controlled by clock. Modern CPU can run in 5 GHz clock. Now let's move on to the speculation. CPU microprocessor invests heavily in design to make accurate predictions at the beginning of the pipeline. It is called the branch prediction. When a microprocessor executes newer instruction than a branch without knowing if that branch is taken or not, it is referred to as speculative execution. Speculation is where CPU makes prediction on what direction a branch might take and begin executing instructions based on the direction. Now let's move on to the front end. So CPU predicts what instructions are needed. Next to it is fetches them and decoded them into micro-operations, or what we call UOPs. Micro-operations are the strongest connection between the instruction set architecture and the microarchitecture. On the other hand, the back end uses superscalar execution. The simplest form of execution is the arithmetic logic unit, or also known as ALU. If we have single arithmetic logic unit, it is referred to scalar execution, while if the ALU operates in parallel, it is called the superscalar execution. In order to provide the best performance and energy efficiency, executing out of order is much better. It can allow codes execute faster by removing unnecessary wait time. This is Kenneth, and thanks for watching.